Welcome back. In this video, we're doing our continued talk on two-sample hypothesis testing with a focus on Z and T. And in this video, we're going to take our discussion of independent samples and do it specifically with an example in R as we move through these processes. Now, before we talked about confidence intervals and our variance assumptions, so here we're going to do the test in R, and in the future videos, we're going to change gears up to how we can talk about this with paired two-sample tests. So let's go ahead and get started with an example in R. The example I want to show you takes this idea with religion and children. Now, a theological division exists between Protestants and Catholics on the matter of birth control. Generally speaking, Catholics do not support the use of birth control, whereas Protestants don't make such a distinction. A relationship may exist between the use or not of birth control and the number of children in a family. So, if you're not quite sure where I'm going with this, if you use birth control, you're probably not going to have as many children versus somebody who does not, or a couple that does not use birth control, and therefore more likely to have pregnancies and potential children. So that the idea is that Catholics, on average, have more children than Protestants. So we can go ahead and develop hypotheses that Catholics, on average, have more children than Protestants. What is the population? What is the sample? And what are the null and alternative hypotheses? Keep in mind, we're using the General Social Survey 2016, so the GSS, to analyze this. The variable for religious identity is relig, and that's capital R-E-L-I-G. If you're looking in the codebook, it's on page 305, or the PDF version, page 314. The number of children is in the child's variable, codebook page 170, or PDF page 179. And there's also the online codebook for the GSS that I highly recommend rather than having to flip the giant PDF. And you can look and search for these variables as well differently. So go ahead and pause the video to look up the variables, get a sense for these things, and identify the issues like the population, the sample, the hypotheses, and let's come back. I'll wait. Okay, so now that we're talking about this, the idea was that Catholics on average have more children than Protestants. The population, according to the General Social Survey, are all adults 18 or older living in the United States. The sample are those that had participated in the General Social Survey and had answered both the questions related to religious identity and the number of children. So there are going to be some individuals that didn't answer these questions, so they're not part of the sample as it pertains to these variables. They might be part of the broader GSS, but I'm narrowing my scope here. The null and alternative hypotheses. The null says that the average number of children for Catholics is minus the average number of children for Protestants is 0. And that the alternative is that Catholics minus Protestants on average are greater than 0. This is a one-tail test because we're saying that Catholics would be having more children than Protestants due to their selections of birth control, which is why when we do this Catholics minus Protestants, we would get a positive number and therefore identifying it as greater than 0. Now I want to go ahead and explore some of the data here, and what I'm looking at is to see which variables for the independent and the dependent for childs and religions. Go ahead and always look at your data here to really help identify what's going on, get a sense of your variables before you put them into the bivariate test. So, do the variables satisfy the requirements for the t-test? Looking first at religious identity, and I'm using the frec command from the summary tools package on religion, and I'm using an option here, order equals frec, so it actually will sort them based highest with frequency and downward. And what we see here is that there are a ton of religious categories here, far more than what we are able to use in a t-test. So when I go ahead and do this t-test, I'm going to have to do some filtering to look specifically at the Protestants and Catholics or use some other method. When I go ahead and look at the number of children, I'm going to use the Desker function because it's numeric, and it tells me that I get an error back and says that this is not numerical. So I'm going to do a quick deviation from the actual t-test to fix the recode here. And so this is just an example here where I'm doing a table on the child's variable, and it prints out for us. The first row is the number of children, the second row are the number of people that have identified having that number of children. And note at the end it says 8 or more. R saw that 8 or more and says, hey, this is string information, this isn't a number. And so it converted the whole variable of childs into a factor. So what we need to do is change that factor back into some sort of numeric variable. And one little recoding trick that I'm using here is I could go ahead and change the 8 or more into just an 8, and then remember that 8 or more is the actual identifier, and use some sort of like as character and as numeric combination. But in this case, I'm going to use a slightly different trick, and this trick only works when I have an unbroken chain of numbers, going from this case 0 to 8. If I was missing any values in between, like say a 3, this little trick I'm going to show you is not going to work, and you would have to use the longer code version. So I'm recoding this into a new variable I'm calling childs.r. I'm running an as numeric, you could also do an as integer, on childs, which is going to strip away the the text labels on top, which are these numbers stored as text. It's relying on the index position underneath. And then I'm doing a -1 because it starts counting as 1. And we count 1, 2, 3, 4 all the way to 9. So I do a -1 off of that to reset my 1 back to a 0 to mean 0 children. And then I can go ahead and reset myself. So when I look at my variables here, the 8 or more is now as an 8, and my frequency counts all match. Everything looks good. I can also do a bivariate table with the original and my recoded variables, and I can just map this out to make sure that each recoded number landed in the expected places that it should. I always recommend you check your recodes to make sure things go the way they are. Now let's go ahead and jump back to the t-test. And the first version I'm going to show you is doing a subset for each one. Now, keep in mind, I have in the top and the bottom 2 different ways that you can run your t-test function. The first one is using the DV, so the number of children of group 1, comma, the DV sorted by the number of children in group 2. What this would come out to if we're doing this out in the code is I'm doing a t-test on my recoded childs, then I'm doing a filter to see if the religion equals Catholic, comma, very important to note the comma here. Then I'm doing the GSS on the child's variable, filtering only by those who identified in the religion variable as Protestant. I'm adding on the extra commands here of pooled equals true and paired equals false. The pooled equals true is relevant because that says that we are pooling our error between these 2 groups, that's including the variance and the n, and the paired equals false because we're not doing a paired t-test, which we'll talk about in the next video. And the alternate version, another way you could do this, is instead of using the comma to separate the 2 different vectors of number of children, I use the tilde, which is the grouping character. So I run t-test on my dependent variable, which is the number of children, tilde my IV, which is a categorical component. So in this case, the code here is a little bit longer and it's a little bit messy, but that's just because I haven't done any sort of subsetting and whatnot. But in this case, we do a t-test on the child's variable. Then I do a square bracket filter to see of those who identified as Catholic or identified as Protestant, tilde, not a comma, GSS religion variable, only those identified as Catholic or identified as Protestant. Again, comma pooled equals true, paired equals false. And if you're wondering why I had to do that filter on both the child's and religion variable, because if I didn't, R is going to try and get all of the values, including those that we don't want with those 2 religions, and it's going to give you some sort of length error or other issue. Now, just to kind of break this out so it's a little bit more readable with the IV subset version, I can go ahead and split this up onto different rows so it's a little more legible, and I'm also breaking it out here for you so you can study the syntax of the code a little bit. Now, here's another version. If I don't want to go through so much of the big messy filtering and whatnot, I can also make another variable that just takes the 2 categories of religious interest, Catholic and Protestant, and I'm assigning them into a new value. So what I'm doing is I'm creating a new variable called ivrel, and in this version, I'm using an if-else, but there's all sorts of recode methods you could use. So I'm using an if-else statement to say if it's Catholic in religion, make it Catholic in ivrel. And if it's Protestant in religion, make it Protestant in ivrel. And then make everything else missing. That's going to take all of the other religion groups and kick them out, force them to be missing. So we only have 2 groups into the hard coding. I run a table on ivrel, and it shows that I have only the Protestants and the Catholics. Now when I want to go ahead and plug these in with my new ivrel, it's a much shorter code version. I just run a t-test, GSS $ my recoded child's variable, tilde my ivrel variable, comma pooled equals true, comma paired equals false. And that's going to generate out for us. The t-test results that we're seeing here are going to be the same no matter which of the versions that I showed you. And it's doing the Welsh, because I did not specify that we had equal variances or not. And honestly, I didn't test for them anyways at this point, so you definitely want to go ahead and use the Welsh. And it says that we have a t-test statistic of 0.447, and it keeps going, degrees of freedom of 1,247, and a p-value of 0.65. Note the confidence interval that we get there contains the number 0. Our p-value is larger than our alpha, and it shows that, on average, there are no differences between Catholics and Protestants based on the number of children that they have. Also, if you want, at the bottom, it also shows you what the mean of each of these are. So the mean number of children for Catholics is 2.05, and the mean number for Protestants is 2.019 or 2.02. These differences are so small at the decimal, especially considering we're talking about people, so we have to round up or down into whole numbers. And so it's pretty much the same value for Protestants and Catholics. And with this, I'm going to go ahead and wrap up this particular video here where we were showing you how to do these particular exercises in R. And in the next video, we're going to start talking about the paired sample tests. I'll see you all then.